Helion Energy's historic announcement, the first commercial nuclear fusion power plant in Malaga, Washington. On February 28, 2025, Helion Energy, a nuclear fusion energy company headquartered in Everett, Washington, made waves in the energy sector with its announcement to construct the world's first commercial nuclear fusion power plant in Malaga, Washington. This groundbreaking initiative aims to produce 50 megawatts of clean fusion energy, with operations expected to commence by 2028. Helion's plans come at a time when the global push for sustainable energy is more critical than ever, and the prospect of harnessing fusion energy, often referred to as the artificial sun, is becoming increasingly tangible. Key details of the project. The proposed site for the fusion power plant is strategically located near the Rock Island Dam along the Chelan County side of the Columbia River, on land owned by the Chelan Public Utility District (PUD). While the site selection is still pending finalization, discussions with local stakeholders are actively underway. Helion's communications director Jesse Barton emphasized the importance of community engagement, announcing a public event scheduled for March 11, 2025 at Mission View Elementary School. This event aims to provide further details about the project and facilitate local involvement, a critical step for Helion as it seeks to build support and address any community concerns. The ambitious timeline set by Helion includes breaking ground on construction by summer 2025, pending the completion of necessary permitting processes. The fusion power plant is envisioned not just as a cutting-edge energy facility but as part of a broader strategy to diversify energy sources in Chelan County, which has traditionally relied heavily on hydropower. The partnership with Microsoft. One of the most significant aspects of Helion's venture is its partnership with Microsoft, announced in May 2023. Under this groundbreaking agreement, Helion will supply Microsoft with the first kilowatt-hour of fusion-generated electricity once the plant is operational. This collaboration aligns with Microsoft's sustainability goals and its commitment to transitioning to cleaner energy sources to power its vast data centers. The deal highlights the confidence in Helion's innovative fusion technology and underscores the growing corporate interest in sustainable energy solutions. A broader vision for energy in Chelan County. Chelan PUD's leadership, including Kirk Hudson, has expressed enthusiasm about the potential of the fusion plant to contribute significantly to the region's energy landscape. The PUD has recognized the need to diversify its energy portfolio beyond hydropower, which, while historically reliable, may not suffice to meet future energy demands. This sentiment reflects a broader acknowledgement that energy needs are evolving, requiring innovative and sustainable solutions. The fusion power produced by Helion's facility is expected to not only support Microsoft's energy requirements but also extend its benefits to local customers in Chelan County and the surrounding north-central Washington region. This dual approach aims to ensure that the local community reaps the rewards of this pioneering technology. Economic and employment opportunities. The construction and operation of the fusion plant present significant economic opportunities for the region. Helion plans to hire approximately 130 workers during the construction phase and about 30 staff members for ongoing operations once the facility is up and running. This job creation is particularly welcome news for the local economy, which stands to gain from the influx of skilled labor and associated services. Helion's recent funding achievements, including a $425 million Series F funding round, bring its total funding to over $1 billion. This financial backing is crucial for advancing the development and deployment of fusion technology, positioning Helion as a front-runner in the competitive race to achieve functional fusion reactors. The competitive landscape of fusion energy. While Helion is making significant strides, it is important to note that it faces stiff competition from other companies also vying to establish functional fusion reactors. The quest for achieving a sustainable fusion reaction that can produce usable power has seen various entities worldwide making substantial advancements. For instance, China recently achieved a record of 1,066 seconds of sustained fusion reaction. while the West Tokamak in France surpassed that duration shortly thereafter. These developments underline the challenges involved in fusion energy but also highlight the rapid progress being made in the field. Conclusion: a step towards sustainable energy. Helion Energy's announcement marks a pivotal moment in the pursuit of sustainable energy solutions. As the world grapples with climate change and the urgent need for cleaner energy sources, the development of a commercial fusion power plant represents a beacon of hope. With its ambitious timeline, strategic partnerships, and community engagement efforts, Helion is poised to play a crucial role in the future of energy. As the project progresses towards its 2028 operational goal, many eyes will be on Helion Energy not only to deliver on its promises but also to inspire further innovations in the clean energy sector. The journey toward harnessing the power of the artificial sun is underway, and the implications for energy production and environmental stewardship could be profound. The recent announcement by Helion Energy regarding the construction of the world's first commercial nuclear fusion power plant in Malaga, Washington, presents several counterintuitive elements that challenge common perceptions about energy production, technological feasibility, and the timeline for achieving practical fusion power. 1. Commercial viability of fusion energy. The notion that nuclear fusion, a process often associated with experimental science and long-term research, could soon transition to commercial viability is surprising. Historically, fusion energy has been viewed as something perpetually just around the corner. The fact that Helion has not only proposed a timeline for operational power generation by 2028 but has also secured a significant partnership with Microsoft for the purchase of fusion-generated electricity marks a pivotal shift in the narrative surrounding fusion. This contrasts with the prevailing skepticism about whether fusion could ever be harnessed for practical use. 2. Microsoft's early commitment. The fact that Microsoft has signed an order for Helion's first kilowatt-hour of electricity is particularly striking. Microsoft, a tech giant heavily invested in sustainability and renewable energy, is betting on a technology fusion that has historically been fraught with uncertainty. This move signals a strong belief in Helion's potential to deliver on its promises, suggesting that major corporations are willing to make substantial investments in fusion energy, which could redefine energy sourcing for large-scale operations. 3. Public utility districts' role in fusion development. The involvement of the Chelan Public Utility District (PUD) in the development of a fusion plant is unexpected. PUDs are typically associated with conventional energy sources, primarily hydropower, in this region. Their willingness to diversify into fusion energy reflects a significant shift in energy strategy as the district acknowledges the limitations of relying solely on hydropower. This transition from traditional energy models to innovative, cutting-edge technologies signifies a broader acceptance of fusion as a legitimate energy source. 4. Workforce impact and economic growth. Helion's announcement includes plans to hire 130 workers for the construction phase and 30 for ongoing operations. This focus on job creation in a field that is often seen as niche or overly technical is counterintuitive. It suggests that fusion energy could not only contribute to sustainable energy but also drive economic growth and job creation in local communities, challenging the perception that advanced energy technologies primarily benefit large corporations or affluent investors. 5. Funding dynamics in fusion research. Helion's ability to raise over $1 billion, including $425 million in a recent funding round, indicates a robust investor confidence in the future of fusion energy. This level of funding for a technology considered experimental is counterintuitive, as many investors traditionally shy away from sectors perceived as high risk. The substantial financial backing suggests a belief that the fusion energy sector is on the cusp of a breakthrough, potentially disrupting traditional energy markets. 6. Community engagement and local involvement. Helion's proactive approach to community engagement, such as hosting informational events for residents, contrasts sharply with the typical top-down approach often seen in energy projects. The expectation that local communities will be informed and involved in the development of such a groundbreaking project reflects a shift towards more inclusive practices in energy development, recognizing the importance of public buy-in for the success of large-scale energy initiatives. 7. Timeline for fusion power. The ambitious timeline set by Helion to begin construction by summer 2025 and operational power generation by 2028 seems optimistic. Given the history of fusion energy projects, which have often faced delays and technical challenges, this assertiveness in declaring a timeline challenges the narrative that fusion is always decades away, suggesting a new era of accelerated progress in fusion technology. 8. Environmental considerations. The integration of an environmental impact report into the timeline for project approval reflects a growing recognition of the need for sustainable development practices even in the pursuit of advanced technologies like fusion. This could redefine how future energy projects are approached, emphasizing not just the technical feasibility but also the environmental stewardship associated with energy production. In summary, Helion Energy's plans for a commercial nuclear fusion power plant encapsulate several counterintuitive aspects of energy production, regulatory practices, corporate investment, and community engagement. These elements challenge traditional views about the feasibility and timeline of fusion energy, suggesting a potential paradigm shift in how society approaches energy sourcing and sustainability. The announcement that Helion Energy plans to build the world's first commercial nuclear fusion power plant in Malaga, Washington, marks a significant milestone in the pursuit of sustainable energy. While many people may focus on the groundbreaking aspects of this venture, several important details and implications are likely to be overlooked. Here we will delve into these nuances and explain their significance. 1. Location choice and its strategic importance. Helion has chosen an abandoned power station site in Malaga near the Rock Island Dam. This decision is strategic not only because of the existing infrastructure but also due to the proximity to the Columbia River, which can provide cooling water necessary for the fusion reactions. The site selection process is still ongoing, and community engagement is a key component. This engagement is significant because local support can be crucial for project success, potentially affecting permitting processes and public sentiment towards nuclear energy. 2. Community engagement initiatives. The community event scheduled for March 11, 2025 is an essential platform for informing and involving local residents in the project. This initiative goes beyond mere transparency. It fosters community buy-in, which is vital for mitigating opposition and ensuring that local concerns are addressed. Engaging the community can also lead to additional support from local businesses and stakeholders, which can be instrumental in the project's long-term success. 3. Partnership with Microsoft. The partnership with Microsoft is not just a commercial agreement, it signifies a major endorsement of Helion's technology. Microsoft's commitment to purchase the first kilowatt-hour of fusion electricity underscores the tech giant's commitment to sustainability and clean energy. This partnership could attract other corporations to consider investing in or collaborating with Helion, creating a ripple effect that could accelerate the adoption of fusion technology across various sectors. 4. Workforce development plans. Helion's plan to hire approximately 130 workers for construction and about 30 for operations is significant from an economic perspective. It indicates a commitment to local job creation, which can enhance community support for the project. Furthermore, the development of a skilled workforce in the burgeoning field of fusion energy can position the region as a hub for clean energy innovation, attracting further investment and talent. 5. Funding milestones and financial viability. Helion's recent funding round, which raised $425 million, is a crucial detail that illustrates investor confidence in the viability of fusion technology. With over $1 billion raised in total, this financial backing is significant because it demonstrates a shift in the perception of fusion energy from a theoretical concept to a practical and investable technology. This funding is essential not just for the construction of the plant but also for ongoing R&D that will be necessary to overcome technical challenges and improve efficiencies in fusion power generation. 6. Energy diversification strategy. For Helion PUD, the fusion plant represents a strategic move towards diversifying energy sources. Historically reliant on hydropower, this shift signals an acknowledgement of the need for a more robust and resilient energy portfolio. As climate change and energy demands evolve, diversifying energy sources can enhance energy security and reliability, particularly in regions prone to drought or other hydrological challenges that could impact hydropower generation. 7. Technological competition and innovations. Helion is entering a competitive landscape where multiple companies are vying to achieve operational fusion. The challenges of sustaining a fusion reaction long enough to produce net positive energy are well known. Understanding Helion's technological approach and its prototype developments such as the Polaris reactor can provide insights into the innovations driving this field. The competitive dynamics could lead to accelerated technological advancements benefiting the industry as a whole. 8. Regulatory and environmental considerations. The need for environmental impact assessments and regulatory approvals cannot be understated. The public's perception of nuclear energy, particularly after historical events, means that Helion will need to navigate a complex regulatory landscape while addressing environmental concerns. Successfully managing these hurdles will be critical not just for the Malaga plant but for future fusion projects across the globe. 9. Long-term impact on energy markets. If Helion successfully deploys its fusion power plant, it could reshape energy markets, particularly in how clean energy is perceived and utilized. The potential for abundant carbon-free energy from fusion could lead to reduced dependence on fossil fuels and a shift in energy pricing structures, potentially making clean energy more accessible and affordable for consumers. 10. Global implications of successful fusion technology. Finally, the successful commercialization of fusion energy would have profound implications for global energy policy and climate change mitigation efforts. Fusion offers a path to virtually limitless energy without the associated long-lived radioactive waste of fission reactors. If Helion and others succeed, it could redefine energy security and environmental stewardship on a global scale. Conclusion. The announcement of Helion's fusion power plant in Malaga, Washington is a watershed moment in the journey toward sustainable energy. The details surrounding location, community engagement, partnerships, workforce development, funding, and regulatory challenges are crucial for understanding the broader implications of this project. As Helion moves forward, the intersection of technology, community involvement, and environmental considerations will be key to determining the success of this groundbreaking initiative. Ignoring these details could lead to an incomplete understanding of the potential impact of fusion energy on the future of energy production and consumption. 1. Strategic location and community engagement. The decision to build the world's first commercial nuclear fusion power plant in Malaga, Washington is significant not only for its technological implications but also for its socio-economic dimensions. The site, on land owned by the Helion Public Utility District PUD near the Rock Island Dam along the Columbia River, symbolizes a strategic choice aimed at leveraging existing energy infrastructure. Helion's commitment to engaging with the local community, including plans for a public event to discuss the project, reflects an understanding of the importance of local support and transparency in large-scale energy projects. This engagement is crucial for addressing community concerns, fostering goodwill, and ensuring that the benefits of the plant extend to local residents and businesses. 2. Partnership with Microsoft. Helion's agreement with Microsoft to supply fusion-generated electricity marks a landmark moment in the commercialization of fusion energy. By securing a contract for its first kilowatt-hour of fusion electricity, Helion not only demonstrates the viability of its technology but also aligns with Microsoft's sustainability goals. This partnership highlights the growing demand for clean energy sources from major corporations and serves as a validation of Helion's technological advancements. It also sets a precedent for future corporate partnerships in the energy sector, where tech companies are increasingly looking to secure reliable carbon-free energy supplies. 3. Funding and workforce development. Helion's successful fundraising efforts, including raising $425 million in a recent funding round that brought total funding to over $1 billion, play a critical role in the project's feasibility and timeline. This substantial financial backing indicates strong investor confidence in the company's vision and technology. Additionally, Helion's plan to hire approximately 130 workers for the construction phase and 30 for ongoing operations underscores the project's potential to create jobs and stimulate the local economy. This aspect of workforce development is vital as it emphasizes the dual benefits of technological innovation, advancing energy solutions while also addressing local employment needs. 4. Technological advancements in fusion energy. Helion aims to develop a 50-megawatt fusion power plant, which represents a significant step toward making nuclear fusion a practical energy source. The challenges associated with achieving stable and sustained fusion reactions are well documented, and Helion's ongoing work with its seventh reactor prototype Polaris is crucial for demonstrating the technology's viability. The race among companies to establish functioning fusion reactors adds a competitive dimension to the field, driving innovation and potentially accelerating breakthroughs. This aspect of technological advancement is not just about energy production. It also poses broader implications for global energy policies, carbon reduction strategies, and the future landscape of renewable energy sources. 1. The Manhattan Project 1942–1946. The Manhattan Project was a secret research and development project during World War II that aimed to develop the first nuclear weapons. Led by the United States with the support of the UK and Canada, the project culminated in the creation of the atomic bomb. Key figures included scientists like J. Robert Oppenheimer and Enrico Fermi. The project not only marked a significant technological achievement but also raised ethical questions about nuclear weapons use and the consequences of atomic energy. The successful detonation of the first atomic bomb in test conditions on July 16, 1945, at the Trinity site in New Mexico was a pivotal moment in scientific history. 2. Chernobyl disaster 1986. The Chernobyl disaster was a catastrophic nuclear accident that occurred in April 1986 at the Chernobyl nuclear power plant in Ukraine, then part of the Soviet Union. A reactor explosion released large amounts of radioactive particles into the atmosphere, leading to widespread contamination. The disaster resulted in the evacuation of thousands of residents and has had lasting health and environmental effects. It highlighted the risks associated with nuclear energy and led to significant changes in nuclear safety protocols and policies worldwide. The incident also sparked increased scrutiny and debate over nuclear energy's viability as a power source. 3. The ITER Project 1985–present. The International Thermonuclear Experimental Reactor ITER is a large-scale international research project aimed at demonstrating the feasibility of nuclear fusion as a large-scale and carbon-free source of energy. Located in France, ITER brings together scientists and engineers from 35 countries including the EU, the USA, Russia, China, Japan, South Korea, and India. The project aims to achieve net energy gain from fusion reactions and serves as a crucial step toward developing commercial fusion reactors. ITER's ambitious timeline and international collaboration reflect the challenges and potential of utilizing fusion energy, similar to Helion's efforts to commercialize fusion technology for electricity generation. The announcement by Helion Energy regarding the construction of the world's first commercial nuclear fusion power plant in Malaga, Washington, marks a significant milestone in the pursuit of sustainable energy solutions. This facility, designed to generate 50 megawatts of fusion power, is expected to begin operations by 2028, with Microsoft already committed to purchasing its first kilowatt-hour of electricity. As the world moves towards cleaner energy sources, Helion's project raises the question, is the artificial sun truly on its way? Predictions for the future of nuclear fusion energy. 1. Increased investment and research. The successful funding round of $425 million that Helion Energy recently completed is indicative of a broader trend in the fusion energy sector. As governments and private investors recognize the potential of fusion as a clean energy source, we can expect a surge in funding for fusion research and development. This will enable companies like Helion to refine their technologies, making fusion energy more viable. 2. Technological advancements. With Helion's Polaris reactor prototype demonstrating promising results, it is likely that further technological advancements will emerge. These innovations could lead to increased efficiency in fusion reactions, making it possible to sustain reactions longer and produce more energy than consumed. As Helion and other competitors continue their research, we may see breakthroughs that accelerate the timeline for operational fusion reactors. 3. Commercialization of fusion power. By establishing a commercial fusion power plant in Malaga, Helion is paving the way for the commercialization of fusion energy. If successful, this project could trigger a domino effect leading to the development of additional fusion plants worldwide. Other companies will likely follow suit, recognizing the market potential for clean energy solutions and the need to meet global energy demands. 4. Impact on energy markets. As fusion energy becomes more prevalent, it has the potential to disrupt existing energy markets. The introduction of a reliable and virtually limitless energy source could reduce dependence on fossil fuels and other traditional energy sources, leading to a decrease in energy prices. This shift could also stimulate economic growth, particularly in regions that embrace fusion technology. 5. Regulatory developments. The permitting process for fusion plants is crucial for their development. As Helion navigates this process, it may influence future legislation and regulations surrounding fusion energy. Governments may expedite approvals and create favorable regulations to encourage fusion projects, recognizing their potential to contribute to climate goals and energy security. 6. Community engagement and acceptance. Helion's commitment to engaging with the local community in Malaga reflects a growing emphasis on public acceptance of new technologies. For fusion energy to thrive, community support will be essential. Future projects may hinge on effective communication and collaboration between companies and local stakeholders to address concerns and highlight the benefits of fusion energy. 7. Sustainability and climate goals. As the world grapples with climate change, the role of fusion energy in achieving sustainability goals will become increasingly significant. The transition to zero-carbon energy sources is critical, and fusion has the potential to provide a substantial contribution. If successful, Helion's project could inspire similar initiatives worldwide, leading to a global shift towards cleaner energy. 8. Global competition in fusion energy. Helion is not alone in its pursuit of fusion energy. Numerous companies and research institutions are racing to achieve the first commercially viable fusion reactor. This competition will likely drive innovation and speed up the development of fusion technologies. Countries investing in fusion research may also foster international collaboration, sharing knowledge and resources to accelerate progress. 9. Job creation and economic opportunities. Helion's projections indicate that the construction and operation of the fusion plant will create jobs in the region. This trend may extend beyond Malaga as the growth of the fusion energy sector spurs demand for skilled workers in engineering, research, and operations. The fusion industry could become a significant employer, contributing to local economies and workforce development. 10. Long-term energy security. The successful implementation of fusion energy could lead to enhanced energy security for nations. With a virtually limitless fuel supply derived from hydrogen isotopes, fusion has the potential to provide a stable energy source that is less susceptible to geopolitical tensions and supply chain disruptions. This prospect could reshape energy policies and strategies worldwide. Conclusion: the future of nuclear fusion energy is poised for dramatic transformation, with Helion Energy's venture in Malaga representing a pivotal step towards realizing this potential. As investment, technological advancements, and community engagement converge, the dream of harnessing the power of the stars may no longer be a distant vision but an imminent reality. The next few years will be crucial in determining whether fusion energy can fulfill its promise as a sustainable and transformative energy source, ushering in a new era for global energy production.